Alright guys, today we're going over 10.7, the area of a circle. So first off, what is a circle? Well, a circle is a collection of points, each of which is equidistant from a center point, or a collection of points which are all the same distance from a center point. We call this distance the radius, as you'll see here. So the distance from the outside of a circle to the center is always the radius. Another term that we use often with circles is the diameter. Now the diameter is twice the length of the radius, right? The diameter is just a straight line from one end of the circle to another end that goes through the center. Hopefully you should all know these terms or have at least heard of them by now. Now we'll get into more of the definitions part. The area of a circle is the length of the radius, we just talked about, squared times pi. Okay? Pi is a number that mathematicians have come up with that helps us, for its pretty much only specific purposes, to help us find these areas and circumferences of a circle. So there should be a little pi number on your calculator that you can use. So if we have a radius of 3, it would be pi times 3 squared, or 9, so you'd get the answer 9 pi. You can either leave it as 9 pi, or you can multiply 9 by the symbol pi to get a more exact answer. We will not be working, we do not need to focus on measuring the circumference of a circle right now, so you can ignore that. But it is important to remember always that the radius is half the length of diameter, or that the diameter is twice the length of the radius. All right, your first question, if you choose to accept. Just kidding, you have to do it. If we have a diameter of 12 for this given circle, what is the area of the circle above? All right, hopefully you guys all got that one correct. Now we'll move on to a different and probably a little bit more complex idea of a circle. Now we'll be talking about sectors. Okay, what are sectors? Sectors are a portion of a circle that are defined by 2 points along the outer side of a circle. So you see here we have point A and point B. Now we create this sector, the shaded part right here, when we draw radians from the center to these points outside of the circle, and we make the sector is all the area in between these two radiuses, or radian. Okay, so you see here it's kind of like taking a chunk out of a pie, right? You know, you cut right here and you cut right here, you're going to have this little piece of cake or pie or whatever that's going to have some sort of tangible area, okay? And we're going to talk about right now how we can calculate the specific area. So looking at this example here, we have a full circle again. We're given a radius, actually two radii or whatever, and we're told it's a length of 4. And here we have a sector that I've kind of drawn in with this color. So we are now going to talk about how we can calculate this area right here with just the information we're given. The first thing we're going to do is first calculate what the area of the total, the area of the total circle. Okay. Here we have that the radius is 4, and we are told, and of course we know that the area of a circle is pi r squared. So that means the area of this circle will be pi r squared, which in this case will be pi, oh, that was a bad parentheses, times 4 squared, which we will leave for right now as 16 pi. So the total area of this circle is 16 pi. Now I want you to just abstractly for a second look at this drawing. I think it's a fair assessment to say that this piece that's cut out right here is a fourth of this total triangle, right? Kind of like last section when we were breaking up polygons into equal pieces, equal triangles. I think you could fairly say that this piece right here is 1/4 of the total circle. So what we can honestly say is, well, if this is 1/4 of the circle, then, well, the area of this sector, the area of the sector, should just be 1/4 of the total area of the circle, which would give us the answer 4 pi. So again, the area of the sector will be equal to 1/4 times the area of the whole circle. Now, it worked out great. We were able to get this answer in this specific example because it was pretty obvious to us that this was 1/4. But now, how can we find a more tangible way of kind of deciding what percentage the slice is of the whole thing, right? If we always can find out what percentage of the total area this sector is, or this slice is, then we can always just multiply that by the total area to get our answer. So the answer to that question is we use the angle that makes up the sector. So there are 360 degrees, right, in a full circle, right? That it takes 360 degrees to go around that. In this specific case, where this piece is 1/4, we see right here that this is a 90-degree angle, right? So what we can do to always find out the percentage of what this sector is, we can say that, well, we have a 90-degree angle that makes up the sector out of the 360 total possible angles that make up this circle, excuse me. And if you simplify that, you figure out, well, 90 degrees is 1/4 of 360 degrees, so that must be exactly the percentage of what the sector is compared to the whole circle. So if we put this equation now into an actual formula, we could find out that the area of a sector is equal to the angle of that specific sector over 360 times pi r squared, or again, just the area of the total circle. Okay, so again, the area of one specific sector is the angle that makes up that sector over 360 degrees times pi r squared. Again, the area of the total circle. So if this doesn't make sense to you right now, maybe just rewatch this segment again and it should clear it all up. All right, and now we arrive to question number 2. If we are given the information above, let's make it easier this time. Just tell me what fraction of the circle's area is equal to the area of sector ABC. So again, if we know the area of the total circle, what fraction of that area is going to be equal to the area of the segment of the sector ABC? Also, very quickly before we move on, I want to go back and address that the way we name a sector is by in this case it'd be sector ACB. You name one of the points that's on the outside of the circle, then you name the center of the circle, and then of course the last point that makes up the sector. So again, it's almost kind of like naming an angle, right? Sector ACB is going to be equal to kind of that angle right here that we were talking about, right? All right, moving on to the last thing we're going to learn about circles today is called the segment of a circle. So here, we kind of, as we just talked about sectors, we kind of have a sector here, AOD, right? This whole thing, this white and this blue part is sector EOD. But now what we're talking about is a segment, okay? A segment is the area of a circle. Sorry, let me start over really quick. So basically, any part of a circle bounded by an arc, which is this outer area right here, or I think it's drawn right here, an arc, just a segment of the outer part of the circle, so any part of a circle bounded by this arc and a segment joining its endpoints. So here's the arc, and then this arc has two endpoints, ED, and then it has a line joining it. That's going to be what we call segment of a circle. Okay? So basically it's taking 2 points anywhere on a circle and just drawing a line between them, and then all that area to the right of them would be a segment. So what we have here. So sometimes what we're going to want to find is the segment of a circle. We're going to want to find this area, okay? Which looks really complicated, but when we break it down into steps that we already know, it's not that difficult. So here, what I'd like to do now is to help explain how we're going to solve the segment of a circle is bring in the circle that we've already calculated the sector area for, okay? But now, instead of finding this entire area, what we want to do is find just the area that looks like this, okay? Just this area right here. I join these 2 points where we first just had a sector, right? Back here we found the area for this whole area, but now we want just this back area, this segment. So how do we find that? Well, I think it's first important to notice that we did find the total area of this area before, right? We found it to be 4 pi. So this whole area, this triangle, if you can see now, we've kind of formed a triangle. This triangle and this green thing, this green sector, added together all equal 4 pi. So if we can find the area of this triangle, the area of this segment right here would be 4 pi, the total area of this whole piece, minus this triangle, right? So this area of this triangle. Now luckily, we have all the information we already need to solve for this area of the triangle, right? Last section we learned a nifty little formula involving knowing 2 sides of a triangle and the angle in between them, right? If we know 2 sides of the triangle and the angle between them, we can find the area using this equation right here. So we know that this radius is 4. We automatically know that this radius is 4 because all radiuses are the same. So we can say that the area of this triangle is equal to 1/2 4 times 4, 1/2 times 4 times 4 times the sine of 90 degrees. Now when you do all that out, when you do all that work out, it comes out to be 8. So the area of this segment right here is 4 pi minus 8. And you can just leave it like that, and that would be your answer. So here we're going to end on question 3. So here I've used the drawing we had before to kind of help us to just illustrate what we just learned, hopefully through this question. So we have a radius here of 6 of OE. We have the sector EOD, I've told you, is equal to 36 pi. So the area of this whole sector is 36 pi. This angle right here, angle DOE, is 90. So I want to know what the area of this shaded segment is using the formula and process we used about 2 seconds ago.